So you reviewed these yesterday. You can have your little booklet obviously out for the notes. You can't have it on a quiz or a test. So let's refresh. A to the m times a to the n is a to the? No. No. M plus n. When you're multiplying bases, you add the exponents. A to the m to the n is a to the mn. There's where you multiply. So let's just pause and talk about the difference. Here there's two bases. Here there's one base. When there's two bases, you add. When there's one base, you multiply. Okay, two bases you add, one base you multiply. AB to the m just says that we can distribute the exponents, so this becomes a to the m and b to the m. Same deal when it's a fraction, a to the m on the top, b to the m on the bottom. Hello.
How are you?
I'm good. She is. No, she's not. No, she's not.
She's supposed to be here.
Yes.
Who does she think she is?
Exactly.
We're playing a practical joke. You just destroyed it.
It's right there, Mr. Tacky. What the fuck?
I can't believe it.
That's not what we were funny. She was with you?
She was with you.
Nice. When you're dividing bases, when you divide bases, subtract m minus n. Division, subtraction.
Just for the record,
That would have been funny, actually.
I was going to do something, like I was going to make it so it was going to be all X. It is so.
So the last part of this unit, all we're doing is simplifying. You did this last year. The only thing we're adding in new, if you peek, is suddenly we're going to have fractions as bases and fractions as exponents. That's the only thing that's new. You've done these kinds of questions last year. They just didn't have scary fractions. Step number 1, follow bedmass. Within bedmass, or use your exponent laws. In terms of bedmass, this is multiplication. So when you hit the m in bedmass, it's that law that you're going to use. This will be E, this will be E, and this will be E, just depending on what the question looks like. Those are all part of the exponent piece in bedmass. And the last one is? Division, right? Because it's a division. Tim, you're going to take your earphone out? Grab your paper. Did you want to just borrow some from over there? You would have done questions like this last year. The only difference is we wouldn't have given you a base that was a decimal. So we might have given you 2 to the negative 6 times 2 to the 8, but never 0.2 and 0.2. That's the only thing now is we're just adding decimals and fractions. Bedmass, what comes first? Brackets. Are there any brackets? Nope. What comes after brackets? Exponent. Can I do anything with this negative 6? Okay, so you can flip to here. Does it look like this? Does it look like this? Does it look like this? That tells you there's no E steps. What comes after E? Multiplication or? So now you're looking, does it look like the first law or like the last law? It looks like the first law. So this exponent law says if we are multiplying bases, what do we do with the exponents? We add them, so we keep the 0.2. And you don't normally need to show this step. I'm just going to show for the first one, we're adding negative 6 and 8. And then add them together. What is negative 6 plus 8? 2. What is the difference between the directions of evaluate and simplify? Because that was a mistake on the first quiz a lot of you made. What's the difference between evaluate and simplify? Andrew. Yeah, evaluate means gives me the answer. So if I said evaluate this, you would grab your calculator and you would do 0.2 to the exponent of 2 and you'd write down a number. Did the directions say evaluate? It just says simplify. Simplify means makes it smaller, make it more compact, make it easier. This is obviously more simple than this guy over here. So just be aware in this unit if the question is saying evaluate versus simplify. Evaluate, you would just plug this onto your calc, not what the question wants. Number 2. Scariness going on. There's fractions and more fractions and brackets and double brackets. I'm going to rewrite the question for non-visual people, because for non-visual people this is a lot going on. So all I'm going to do is I'm going to put an x in here instead. Okay, all I did was take that negative 3/4 out for a second. I'm just going to put x's in. Bedmass says brackets first, so what can I do in the brackets? Nothing. Now exponent. Okay, so take a look at this. Take a look at the laws, either on the last page or in your booklet. Which law does this look like? There's a 2 right there. And then the negative 3. So all I did was take the fraction out for now. Okay. Which law does this look like? Power of a power. And power of power says if there is 1 base and 2 exponents, we multiply. So this is going to become x to the. This one's a 3? Thank you. Was that what you were trying to tell me? Are we good now? Everything else is good? Okay. So this is power to a power that says if we have 1 base and 2 exponents, we multiply. So what's negative 3 times 3? Negative 9. Are we okay there, what I've done? This one is the exact same thing, power to a power that says if we have 1 base and 2 exponents, we multiply. So this is x to the 6. Well, what is the operation that was in between these? Multiply. So you can put a dot if you want to. You can bracket them if you like that. You just can't put an x. Why can we not put an x for multiply? Because then we're a variable multiply, it's all confusing. Okay, take a look at this. What do you see? Well, if it's a multiplication, that's multiplication law, which says if there are 2 bases, we add the exponent. So I'm going to keep the x. I'm going to add negative 9 plus 6. Again, you don't need to show that step. I'm just showing you when you look back what we're doing. And this becomes x to the negative 3. Still with me? Now we have negative exponent law that we looked at this unit that says, we just don't like negative exponents. We hate them, in fact, and we want to change it positive. So what's negative exponent law? If it's on the top, it goes to the bottom. And if there's nothing else, what goes on the top? A 1. But I didn't really have an x. What did I really have? So what I'm going to do is just put it back in this case. You only need to do this x piece if your brain finds this confusing. If you can do this carrying negative 3/4 all the way down, then do it. It's just some people are used to seeing x, so it's a little bit more friendly for the brain. Okay, take a look. Fraction to an exponent. What does the exponent law say? Fraction to an exponent.
So, for this example, only percent of value that you would continue with.
To get an actual number at the end. Yep.
Okay.
Fraction, exponent. Take a look at the division law. What does it say? Which of these does it look like? This one. What does it say? Not really multiply them out, but give the exponent to each part. So I can write this as negative 3 to the 3 and 4 to the 3. Now, the very last step, we have what we call the complex fraction. And a complex fraction we've talked before is a fraction over a fraction. We don't like that. How do we deal with division of fractions? How do you divide fractions? You flip the second one or the bottom one. So I'm going to keep that one that was there. And all I'm going to do is flip that bottom fraction. So 4 to the 3 is going to go up. Negative 3 to the 3 is going to go down. And what happens when I multiply anything by 1? We get the same. So we get 4 to the 3, negative 3 to the 3. If the question said evaluate, which it does not, we would actually get numbers for this. We know 4 to the 3 is what number? 4 to the 3 is, we memorize this in day 2 of this unit, 64, and negative 3 to the 3 is? Negative 27. That's if the question said evaluate. Does it say evaluate? Nope. Final answer. Take a look at what we started with. Take a look at what we ended with. Which one is more simple? This one. Again, this part with the x's, that's only if your brain doesn't like the negative 3 on 4. You can keep just carrying negative 3 on 4 down all the way to the bottom. It's just some people like the x's better, so that's a choice. Okay, number 3. Why did somebody just sigh? What's wrong with number 3? I know, because there's fractions and there's numbers. It all goes down to bedmass. B says what? So within the brackets, we got to do a bunch of stuff first. What are we going to simplify first, the bottom or the top? So I'm going to start with the bottom. So I'm just going to do this step first. I'm going to leave everything else alone. I'm just going to simplify the bottom. On the bottom, I'm multiplying. And so we go back to our laws. Which of these has to do with multiplying? The first one, and it says, what do I do with the exponents? I add them. So I'm just going to combine this into negative 1/2 plus 3/2. And again, you don't need to show that step. You can jump right to the answer. I'm just doing it step by step. So keeping that 3 to the 7/2 on the top, keeping the 8 on the outside, haven't touched any of that. I'm just going to combine the bottom. How do I add fractions? Common denominator. Do they have common denominator? Yes, okay, once they have common denominator, add the tops and keep the bottom. Lots of people will add the top, add the bottom. So the top is negative 1 plus 3, which is 2. We keep the bottom, which is 2. Last step, can I simplify 2 divided by 2? So it's 3 to the 1. And do I need to write the 1? No. There's the bottom. It's kind of crazy when you think all of this equals just 3. Okay, am I done with brackets, or is there more I can still do in the brackets? There's more. So I'm now going to deal with the top divided by the bottom. Okay, take a look at your exponent laws. Which of these does it look like? The last one. Last one says if I'm dividing, I, oh, thank you. If I'm dividing, I subtract. So I'm still going to leave those brackets. I'm still going to leave that 8 on the outside, not touching them yet. Exponent law says if I'm dividing, I subtract. So I'm going to have 7 on 2 minus 1. How do we divide exponents? Or subtract exponents? We just did it above. What do we need? Okay, so what I'm going to do is just take this outside and just deal with him, and then I'll put him back. What's under the 1 that we don't see? Common denominator between 2 and 1. Okay, so first fraction's not going to change. Second fraction needs to become a 2 on the bottom. 2 on the top. Subtract it. Offer a 5 over 2. Okay, now I'm just going to put it back, so I have 3 to the 5 over 2 times 8. If you'd rather do that work in the question, that's fine. Just some people see it easier to do the fractions outside. Is there anything more I can do within the brackets? No, so we're done B. What comes after B in BEDMAS? Exponent, we have 3 choices. It's going to look like either the first, the second, or the third E. Which one does it look like? It looks at the first one. It says if you have 1 base 2 exponents, what are we doing with the exponents? Multiplying. So this is going to become 3 times 5 halves, or to the 5 halves times 8. Again, you don't need to show that step. I'm just showing the first one step by step how we multiply. How do we multiply fractions? Common denominator. Top times top and bottom times bottom. What's under the 8 that we don't see? A little imaginary 1. Top times top, bottom times bottom. 5 times 8. 2 times 1. Can I reduce that? Final answer. Look back at the question. It is crazy to think all of this is the same as 3 to the power of 20. Math is like magical. You're going to follow BEDMAS. Within each step of BEDMAS, you're always going back to the exponent law and seeing which one it looks like. Let's do number 4. BEDMAS. What comes first? Brackets. Is there anything I can do within the first set of brackets? So do I have any law that deals with 2 different bases like this? No. So there's nothing I can do here. What about over here when I have an x and a y? Nothing. So there's nothing I can do for brackets. Step 2. Exponent. Okay, can I simplify anything with these exponents? No. What comes after exponent? Division or multiplication. So now we're down to 2 rules. We're down to these 2. Well, which does it look like? Is there a division happening? So it has to be this rule. Just because there's 2 different variables, don't let you throw this off. All I'm going to do is just write this in a different order. I'm going to write an x to the negative 1, and then I'm going to follow it with an x to the 4. Then I'm going to put the y squared. Then I'm going to put the y to the negative 3. So when I'm multiplying like that, does the order matter? So does 2 times 1 mean anything different than 1 times 2? So all I did was group them so that you can see we're going to combine the x's together and the y's together. Exponent law says if we're multiplying, we add. So this gives me x to the 3. And over here, we have y to the negative 1. Don't like negative exponents. Ugh, yucky. What do we do with negative exponents? We flip it, so if it's on the top, it goes to the bottom, so my y is going to move down. Where did the minus 1 go? It's still there, but do we need to write it? What's on the top? Ooh, careful, what's on the top? Well, what's still there that I haven't touched? My x cubed is going to stay on the top. Why don't I move him? Because he doesn't have a negative exponent. So we're just going to leave him on the top. How are we doing so far? What we're doing, by the way, is like one example of every kind of question you're going to see. Are there brackets? Nada. Is there anything I can do with the exponents? No. So now I'm down to multiplication or division. This one's fairly obvious. Which law does it look like? The division law. All I'm going to do is circle. I'm going to circle the coefficients. I'm going to circle the w's. And I'm going to circle the g's. So when you got a bunch of stuff going on, you just do them separately. I'm going to do the coefficients first, then I'll combine the w's, then I'll combine the g's. The coefficients, there's no exponent law. It's just division. What is 16 divided by 4? So it just becomes 4. It's just a straight up division. If you can't divide evenly, you would just leave it. Division law says that when I'm dividing bases, what do I do with the exponents? And again, I'm going to write it out step by step. We're going to have 2 subtract negative 4. For the g, we're going to have 5 minus 6. So 4 is going to stay in front, haven't touched it. The reason I wrote it out is because you need to be careful with these double negatives. Because what your brain is going to see is 2 minus 4, and you're going to want to put down minus 2. But because it's minus minus 4, what's going to happen here? It's plus, so we're going to end up with w to the 6. 5 minus 6 is g to the negative 1. Last step, we just take a peek at the exponents. Ooh, hello, iPhone would like to connect. No iPhone. How about still no? That's very odd. What do we do with the negative exponent? Drop it down, so g goes down to the bottom. He still has his 1, we just don't need to write it. What's on the top? So what did we not move? The 4 and the w to the 6. How we doing? Are you getting less scared or more scared? Less scared is good. Number 6, lots of stuff going on here. Lots of brackets, lots of negatives, lots of fractions. We always go back to BEDMAS. It's the first thing that we do. Brackets. I'm going to take away those outside brackets, and I'm going to take away the 2. And I just want you to look at what's inside. What example does this look like? It looks like 4. If I take away those outside brackets and the 2, it looks like 4. What did we do in example 4? We put them together. We wrote the x's together and the y's together, and then we combine. I'm going to color code because I'm a color person. So I'm going to start with the x to the half, and then I'm going to write right beside it the x to the 3/4. Then my y to the minus 1 and y to the minus 3. And then I'm going to keep those big brackets in the 2, but I'm not really looking at it. I'm not worrying about it. I'm just keeping them on the outside there. Okay, so the stuff in the middle, after we grouped them, what did we do in example 4? We added. Why did we add? Because it's multiplication, so we're going to have to add the x's and add the y's. So still keeping those big brackets, keeping the 2, not worrying about it, not freaking out, just kind of ignoring it. And again, I'm writing this step by step. So we're going to have to add a half plus 3/4, which we'll worry about in a second. What about the y? So minus 1 plus minus 3 is minus 4. I like to do the fraction stuff outside. If you like to do it in the question, that's fine. How do we add fractions? Common denominator. What's common between 2 and 4? 4. 1/2 is going to become 2/4. 3/4 is going to become 3/4. Add the tops. 5, keep the bottom. So we get x to the 5/4. I'm going to keep my y to the 4. I'm going to keep my big brackets. And I'm going to keep the 2. So all I've done at this point is just simplify inside those brackets, and it was exactly like question number 4. Now I got to worry about these brackets. Well, take a look at our laws. Exponent, 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 it's got to be one of these 3. Which one does it look like? So it's probably not this one because we don't have a division. We're down to these two. What's the difference between them? There's two different things in the brackets. This has one thing in the brackets. Well, which do we have? Two different things. And so the exponent law says we just give the exponent to both of them. So we're going to give the 2 to the x and we're going to give the 2 to the y. What are we going to do? Multiply it or add it? It's a multiplication. So we're going to have an x to the 5/4 times 2, which I'll do in a second, and a y to the negative 4 times 2. I'll deal with this guy over here. So 5/4 times 2. How do we multiply fractions? Bottom times bottom. What's under the 2 that we don't see but we know is there? That's the right one. Top times top. Bottom times bottom. Can we reduce? 5/2. Okay, so all the way back here, I got an x with a 5/2. The y is a little bit easier, no fractions, thank goodness. Y to the negative 8, confirm. What's the very last thing I need to do? Move that negative exponent. Don't like him, so where does he go? Down to the bottom. What do I do with the x to the 5/2? Put it on top. Are you beginning to see patterns between the questions? Show me your thumb so far. Good, I'm okay with here right now. Number 7, lots going on in this one too. If I take away those outside brackets in that exponent and just look at what's inside the brackets, which example does it look like? So which example does the inside look like? Like 5. So check back number 5. What did we do? We just did the division. So I'm going to circle the coefficients because they're going to go together. I'm going to circle the A. What am I going to do with B? It doesn't have a friend. Yeah, I'm just going to leave it. So I just won't worry about B for now. 16 and 64, can't divide them, but can I reduce them by anything? I can divide them by bigger than 8. 16, I can divide them each by 16. So what's 16 divided by 16? And I'm just going to write it as imaginary because we know that it's not there, but it's there. And what's 64 divided by 16? 4. Okay, so if you're not sure where that came from, I'll just do it outside. Okay, so if we reduce it, we get 1/4. Division of the A's says we take the exponents and subtract them. What's on the top that we don't see? A 1, so a 1 minus 4 is going to give me A to the negative 3. And what did we say we're going to do with that B? We're just going to leave them where it was. So that was question 5. Now we just need to deal with this exponent on the outside. Which of the 3 E laws does it look like? This one because it's got a fraction. And the exponent law says we just give that exponent to everything. So the 2/3 is going to be given to the A, it's going to be given to the 4, and it's going to be given to the 3, to the B. Oh, we don't worry about the negatives till the end. So I'll move them around as the last step. Okay, what are we doing with the A when we give it that 2/3? So it's going to be the negative 3 over imaginary 1 times 2/3. Offer of negative 2. Giving it to the 4 just means it becomes 4 to the 2/3. There's nothing else I can combine there. What about the B?
Good morning, Huskies. Come on down and get your movie trivia, grade board, answer sheet. I'll have them here in the office for the next 3 or 4 minutes, and then we're going to get started. Thanks so much.
Do you want to play or do you want to finish the examples? Okay, somebody's got to run down and get it. What's happening with the B? So negative 1/3 times 2/3. Offer of negative 2/9. Can we reduce that? Last step, negative, negative, don't like it. Where's the A going to go? To the bottom. Where's the B going to go? It's already on the bottom. But if we want to turn it positive, it's going to go to the top. What about the 4? Stay where it was. Example 8. What example does it look like? Example 8. What example does it look like? 6. So find a friend, someone sitting in front, behind, beside you, have 6 right beside, try it together. Or be antisocial.
Down in the office before the bell. Have a great day, everyone.
Who got it? Good job.